Welcome to Brain Vision.
Okay, here's our thermometer before and after the expansion of mercury. Real quick, we should look up the volume expansion coefficient of mercury, which is 1.82 times 10 to negative 4 inverse degrees Celsius. Now we can look at the volume expansion equation. Delta V is equal to beta V initial times delta T. We know that our volume equation for a sphere, which is the initial volume of mercury, it just fills this spherical bulb, is 4/3 pi and then r cubed, which for us is the diameter, half of the diameter, because of course diameter is twice the radius, and we're given the diameter, so we're just going to work in terms of diameters. But this is diameter of the bulb, of course, and that's all cubed times delta T. So let's work in our numbers. Delta V is equal to 1.82 times 10 to the negative 4 times, I'm going to change my brackets here, 4/3 pi, diameter of the ball I had written as 0.250 centimeters. That's going to be halved, and that whole thing's going to be cubed, times delta T, which is given as 30 degrees Celsius. So our change of volume is going to be equal to 4.47 times 10 to the negative 5 centimeters cubed. Now, the change in volume due to expansion has to go somewhere. Like, that value of mercury must go somewhere, and it goes up. It fills the tube, right? And so, well, what do we know about the area of the tube? The volume. The volume of the tube, Vt, is just equal to the area of the base, which in our case is pi r, but we're going to work in diameter, right? So diameter tube over tube squared times the height, which for us is delta h based on our diagram. Now we know that, like I said before, this change of volume goes to this volume in the tube. So we can set these equations equal and solve for delta h. 4.47 times 10 to the negative 5 centimeters cubed is equal to pi. Our diameter of the tube I had as 0.004 over 2 squared times delta h. And you should find that our change of height is equal to 3.55 centimeters.